So one of the things that we want you to be able to do for the EOC or for higher math when you go to college, we want you to understand that the exponential function typically looks like this. Its domain is all real numbers, and its range is the set of all positive numbers. Now, of course, you can move the graph up or down, left or right, but this would be the parent function for an exponential function, and the inverse is called the logarithmic function, and it's going to look like this. Okay. And notice that if you were to shine a mirror, or I guess reflect a mirror through here, notice that the exponential function and the logarithmic function are inverses of one another. And that's why we can use those to solve logarithmic expressions and to simplify or solve exponential functions as well. So kind of know that, keep that in the back of your mind. But what I want to show you today is how to enter some of this stuff in your calculator. It is possible with some versions of the TI-84, and I think some of ours here at Holloway will do it straightforward manner, and some will not. But let me show you how to do it if you perhaps have an older calculator. If you want to know what log base 3 of 3.3 is, take your calculator and you're going to enter log 3.3 divided by log 3. This will help you to estimate that number. So log base 3 of 3.3 is going to be log 3.3. So on my calculator, I would type log 3.3. And the log button is on the first column, about halfway down under the x squared button. So log 3.3 divided by log 3. And it looks to me like that's going to be about it says to round to the nearest thousandth, so that's going to be 3 decimal places. So I'm going to say 1.087. Now, where did that come from? You may have already figured it out. Basically, the numerator is the log of 3.3 because our domain value here is 3.3, and then we divide by the log of the base, and the base is base 3. So how would we rewrite, say, the log base 6 for 13? Well, that's just going to be log 13 over log 6. And if we type that in, again, it's going to be log 13 divided by log of 6. And if I round to the nearest thousandth, that's going to be 1.432. Okay, so let me clear this out and let's move down to the answer page. Not because I want to give you the answer for the sake of argument, but I want you to take your calculator and I want you to go through and do as many of these as you need to until you understand how to get this decimal approximation to the nearest thousandth. So go ahead and pause the video, take out your calculator and type in these. And once you realize what you're doing and you've committed that process to memory, you may stop. But if you need additional practice, you might rewind the video and see exactly what I did and continue from there. So this exercise here is to show you how to rewrite logarithmic expressions in various ways and vice versa. For example, the first few problems say to rewrite each equation in exponential form, and Basically, if you look at problem number 1, you can see that this is log base 6. And the reason we call that base 6 is because we can write it this way, right? Where 6 is the base. And we know that logs are actually exponents. And since I have a 2 here, that means that I have an exponent of 2. And that just means that if you take a base of 6, raise it to an exponent of 2, you get 36. If you look at problem number 2, notice that the base is 289. The exponent is going to be the logarithm itself, which is 1/2. So what do you have? You have 289, which is your base, raised to the power of the exponent, and that's equal to 17. Here we have 14 as our base. That means we could write it this way. The exponent is -2. And notice that that has to equal 1/496. And problem number 4. We have a base of 3 raised to a power of 4, which has to equal 81. And you can reverse the operation. For example, if you are asked to rewrite each equation in logarithmic form, that means you're taking it from exponential form to logarithmic form. It's the same process, it's just the opposite. We know that the base is 64. We know that the exponent is 1/2. So it's going to be log base 64. We know that the exponent is 1/2. And we have 8. Okay, so what about number 6? Well, this is going to be log base 12 of 144 is equal to the exponent, which is 2. Remember, a logarithm just is a fancy way of writing exponents. What about number 7? Well, on problem number 7, notice that our base is 9, so we have log base 9. Our exponent is -2, so we have the -2 here. And let's just make the argument 1/81. Look at problem number 11. On problem 11, we're rewriting each equation in exponential form. So we're going from logarithmic form to exponential form. And here we have a base of u. Our exponent is v, so we have u to the power of v is equal to 15/16. And what I would like to do at this point is to clear the drawing and have you to pause the video and see if you could go through these problems here and actually solve these and get the answers that you see on the worksheet. And just as a review, I would like to go over a couple of problems here. Notice that we're just evaluating, or in this case, simplifying each expression. So what does this mean? Well, basically, if you want to solve for this, you could say, well, what's the answer, right? What is x? What's the unknown? So the question is, 4 as your base raised to what power x would give you 64. 4 raised to what power would give you 64? Well, since 4 times 4 is 16 times 4 is 64, that exponent x, right, would have to be 3. And that's terrible handwriting on my part. Let me change this. Okay, so x is equal to 3. You could take your calculator and you could type in log 64 and divide that by log 4, and you would get 3 again as well. So you could go through and do all of these as just calculator exercises. So again, pause the video and see if you can take the calculator out and convert all of these to the appropriate numbers. If you look at number 31, 31 through 34, we typically do not address this in integrated 3. So I'm just going to leave this for you to see if you can figure out a pattern But notice that we have a base of 12 here and a base of 12 here on the logarithm. And notice that the number here is the number that's still standing. So just kind of study those. I'm just going to say this is optional. We will definitely not be testing you on this. And I would be surprised if we were to see this on the EOC as well. So I'll make this little section here as best I could write it. We'll call that optional.